Welcome to the mole lesson. Okay, so last day we did scientific notation. Today we're going to start learning how to count in chemistry in a way. I'm going to be referring to things like entities sometimes. So whenever I do that, I just want you to know that I'm talking about some sort of substance, like I might be talking about atoms or molecules or ions, but we're going to be counting some entities and so forth. Okay. I hope you watched the video on the introduction to a mole. So um, so in general, we like to refer to the mole as the chemist counter unit. Okay, so there are other counter units that you do use in general. So, for example, counters that we use kind of everyday life are things like a dozen. So, whenever I say dozen or someone says dozen, how many items is that? So, a dozen eggs, that means you have 12. Okay, so another one we use is like a pair of things. Okay, so if it's a pair of things, how many? A pair of shoes, how many shoes? Two. Okay, so now that you understand what a counter is, like a dozen means, 12. A dozen eggs means 12 eggs. A pair of socks means two socks. A pair of shoes means two shoes. So those are counters. So a chemist counter is the mole. So this is an international system of units, SI units. So like centimeters, meters, those are all SI units. Mole is considered to be an SI unit. So whenever you're saying, like meters or seconds and stuff like that, those units that are using in a mole is an example of units. So again, if you were to write centimeter out, all the way out, cm is the abbreviation for centimeter. Well, for mole, it's MOL. Okay, so they just drop off the E. And again, so if you're trying to figure out, okay, well, if it was a mole, how many items is that? Well, it's 602 hexillion. Okay, so 21 zeros. But this is how we would write it in scientific notation here. Okay, so that's what one mole is. So if I say like a mole of eggs, right, it would be 6.02 times 10 to the 23 eggs. Okay, if I say a mole of, you know, candy or whatever, same thing. Okay, so that's how much candy you would have if you had a mole. If you had a dozen things of, I don't know, lollipops, then you would have 12. Okay, but if you have a mole of lollipops, you would have this many lollipops. Okay, so just kind of get comfortable. The reason why we like to use mole is that, to say this number or to say this number over and over again, it's a little bit of a mouthful. So just to be able to say mole is kind of nicer. Okay. All right. So again, so 1 mole is this Avogadro's number, 6.02 times 10 to the 23 entities of a substance. Okay, so entities, there's that again. So I'm just talking about some sort of like it could be atoms, molecules, ions, okay? All right, so that's how many of those there will be. So like, for example, if I had a mole of, atoms, then I would have 6.02 times 10 to the 23 atoms, okay? All right, so again, chemists like to use this because it helps with counting little tiny things that we have to deal with in chemistry, okay? All right, so moving along so we can get to calculating some values all the way through this unit. They call this number Avogadro's constant, okay? And you'll see the symbol capital N, capital A, subscript capital A, used in calculations and so forth. So just get comfortable with that. You'll see other N's. It might be lowercase, might be other capital N's. So just pay attention to if it's N of A, it's Avogadro's number. Okay, and it's something I'll always provide on assessments so that you don't have to memorize it, but hopefully you will have it memorized. Okay. And if you just wanted some background information, they just determined it experimentally, and this is these are the number of digits that we'll use in chemistry 11. When you get to university and so forth, if you're still taking chemistry, the teacher might get you to carry a few more digits along and so forth. Just as we get more and more powerful computers, we can actually get a few more digits on the number as well. It's just like the number pi, right? So, again, so if you wanted to look, like I know you watched the video already, but if you just need another visual display here, Um, and if you're curious on how they came up with the Avogadro's number, they just kind of picked one isotope of carbon, so carbon 12, took 12 grams of it, and then experimentally determined exactly how many atoms of carbon would be in a sample of 12 grams of carbon. And it was Avogadro's number, 6.02 times 10 to the 23 atoms, okay? All right, just in case you want to. I'm not going to test you on that, but if you were curious. Okay, so now hopefully you're getting comfortable with if I say a mole of something, you know it's got to be 6.02 times 10 to the 23. Okay, but we've already studied, like atomic radius already from before. Like, for example, we were studying, looking at the periodic table and analyzing, as we went down, the radius got larger. Okay, and if we went, left, okay, left, it would get larger because you wouldn't have as much effective nuclear charge, okay, because the more protons you have, they'll pull them in. So we've looked at that there's different sizes of the atoms, okay, and back to here. So if I were to, understanding that there are different atomic radii, radius sizes, that if you were to have two different samples of 1 mole, okay, so again, it's like me saying, I'm taking a dozen of these eggs and a dozen of those eggs, and we're looking at how they would compare to each other, okay? So we're looking at, this is carbon on this side and sulfur on this side. So if you look at the periodic table, here's carbon, here's sulfur, okay? So sulfur is lower, okay? So that means it has that extra electron shell, so it's going to have a greater radius. And so if you're looking at 1 mole of both of these, you have the exact number of atoms of carbon and exact number of sulfur atoms. But if you were to fill them up in a container here, sulfur would have a greater volume, right? Because the atoms are larger. Okay, so I just wanted to give you an introduction to what a mole is, and that as we're using it through this unit, you'll have an understanding that it just means that we're looking at how many, atoms there are, could be molecules and so forth that we're looking at in a sample, okay? Because this unit is a lot about calculating out the mass, calculating out how many particles there are, and so forth. So we're going to move on now. That was the mole introduction. We're going to go to the second part of our lesson, which is molar mass. So this is down here. Make sure you have your periodic table handy and a calculator. So we're going to move on to that part there, okay? So molar mass. So what that is it's going to be the mass of 1 mole of substance. So if we were looking again back at these ones here, so we have a mole of carbon, a mole of sulfur, and I wanted to know what the mass is for each of those. So you have the exact same number of particles. So what would the mass be? So for carbon, it'd be 12.01, and sulfur, it would be 32.06. So again, if you were to look just right at the periodic table, you'll hopefully recognize, or maybe recognize those numbers. So here's carbon, so 12.01, there it is. It's the average atomic mass that you guys have been using. So back in, Unit 1, you remember how that carbon is made up of several different isotopes, and they will average out to this mass here, okay? And sulfur, here we go, 32.07. Okay, so this one had 0.06. So that's what we're looking at today, calculating the molar mass of elements. Hopefully you can see that it'll be straightforward, but when they're in compounds, it'll be a little bit, it takes some calculations. So because we're calculating a number today, you're going to be writing units with it. So the units for, like you learned back up there, units for mole is MOL. The units for molar mass will be grams per mole, okay? And the other notes here, so again, molar mass is the mass for 1 mole, so it's the same as saying that's the mass for 6.02 times 10 to the 23 entities. So again, entities you can replace with the word atoms, molecules, compounds, and so forth, okay? All right, so you have the units. Here's a symbol that we're going to use a lot, so capital M with subscript, the substance that you're measuring, so this would be the molar mass of water. Okay, so let's move on to the first one here. So I want you to find the molar mass of neon. So just pay attention to the element symbol, and so neon is a noble gas here. So you always see it just as neon. You need to find the molar mass. So what you're going to do is you're going to go to the periodic table and look for the average atomic mass. Okay, so here it is. It's 20.18. I'm going to go through some steps on how you can go about calculating things. At first, you'll kind of find it annoying because it's like, why did I have to do all that work? But it'll help when you get to some more complex substances. Okay, so the first thing you need to do is look for how many elements are there for like all the elements that are in the compound. But in this case here, it's just neon. So we know that there's only one neon. Okay, so I'm writing one neon. Okay. And then we saw on our periodic table we have 20.18. Okay, and I'm just going to write the units right now, grams per mole. Okay, and then when we calculate that, our answer is 20.18. Okay, so again, that is the molar mass of neon. Okay, let's move on to oxygen. So again, pay attention to how many atoms are in the substance here. So we have 2 oxygens. 2 oxygens. Okay, so we're going to the periodic table and we're looking for the mass of oxygen. So again, if you look here, you're looking at the average atomic mass, so it's 16. So you're going to type in, write in 16. Okay, so again, if you want to write the units at the end, that's fine too. So you end up with, so if you want to actually write this symbol with it too to practice the symbol, so you're going to end up with 32. Okay, grams per mole. Okay, so I'll make the top one neater as well. Okay, so now phosphorus. So hopefully you can see there's 4 phosphorus. So that is, if you're looking on the periodic table, 30.97. Okay, so that ends up being 123.88. Okay, so you want to write it with your symbol here. Actually, I'm just going to go fix something here. What I went through and did was I went through and stacked up the units. So grams per mole, just do it so that it's up and down like that instead of the slash, okay? You're going to find that I'm going to show you a method where when they're stacked up like this, it'll be easier to kind of manipulate the equation if they're stacked up and down. So, all right, so carry on like that. So now we're going to look at compounds, so you're getting a little more complex. So again, hopefully your nomenclature is sound and good to go. Carbon dioxide, what's the formula? Okay, so again, if we can't come up with the right formula, we're going to come up with the wrong molar mass, and the molar mass needs to be used for some other complex calculations, so we have to have the molar mass down. Another thing is, please don't round up, okay? Just carry all the digits here, so the 2 decimal places, okay? All right, so let's do carbon dioxide. So this is a covalent compound, so carbon, right? There's no prefix on it, so we know there's 1 carbon. Di means 2. Dioxide means 2 oxygens, okay? All right, so now we're going to calculate the molar mass of carbon dioxide. So we have 1 carbon. So I'm looking at my periodic table. I have 12.01 as the mass. And I have 2 oxygens. Okay, with a mass of 16. Okay, so again, look at the average atomic mass. All right, so then go through and calculate these out. So you're going to get 12.01, and then you're going to get this one to become 32, and then you're going to add them up, and you're not going to round here. Just carry all the digits along. Okay, and then you get 44.01, and so that is the molar mass of carbon dioxide. Okay, so again, don't just round to 44. Carry the 0.01 and then stack your units up and down like that. All right, now on to aqueous hydrogen phosphate. So again, hydrogen, kind of help you along with the nomenclature here if you're a bit rusty. So hydrogen, okay, has +1 charge, phosphate. So you look over on the other side of your periodic table. Okay, it's a PO4, 3 minus. So when you combine it together, okay, that is your formula there. Okay, so 3 hydrogens. Okay, so let's write this out here. Let's use a different color. So we have 3 hydrogens, 1 phosphorus, and 4 oxygens. Okay, so again, take your time, make sure you're doing these correctly, because the molar mass is used in a lot of calculations in this unit, and if you are not calculating this correctly, it will throw up a whole page of work. So it's important to make sure you're doing these correctly. Okay, so I'm looking up, so again, if you're like, where did I get the 1.01? So hydrogen, the mass is 1.01. Okay, and then I need phosphorus now, 30.97. And oxygen is 16. So just, yeah, I'm looking at my periodic table I have on my desk, but again, if you look here, 16. Okay, so go through and crunch those out. So again, don't round early, and don't round the answer up either, okay? So again, so here, if I take 3 times 1.01, I get 3.03 on my calculator. I don't want you rounding it up to 3 and just using 3, okay? Make sure you use the 0.03. All right, same with the next one here. Carry the 0.97. And then here, again, if you're a physics kid, you will know, you're not supposed to just start chopping numbers off, even like the zeros, right? So anyway, so take those, add them up, and then write all the digits out and keep them all. Okay, so you get 98. Okay, but, oh, that works out nicely. But anyway, just carry the other 2 digits like that. Okay, all right, so yeah, so there's the mass of hydrogen, molar mass of hydrogen phosphate. So basically, if you have, so again, if you're trying to step back and kind of go, well, what is it that we're finding? So if I have 1 mole of all of these substances, so carbon dioxide, okay, that's a compound. If I have 1 mole of it in my hand, the mass that it would have is 44.01 grams. Okay, so here's hydrogen phosphate. So again, same thing. If I just happen to have it in my hand, I wouldn't because it would be corrosive, but if I had it in my hand, I would have 1 mole in my hand. How much of a mass would that be? It would be 98 grams. Keep that in mind, that's what you're finding here. And again, we're going to have to use it in the future as well. So let's go to the next one. So we have calcium chloride. So again, I'll help you with the nomenclature here. I'm just going to see if I can move this up. Oh, and I just remembered, I forgot to write the last one with its symbol here. Okay, so the molar mass, that's the symbol for molar mass of hydrogen phosphate or phosphoric acid, it's aqueous, is 98.98 grams. Oops, grams per mole. Okay, so actually I can write that line all the way under. Okay, and it's still okay. All right, let's move on to calcium chloride dihydrate. Okay, so again, here's help with nomenclature. Calcium always has a 2+ charge. Okay, calcium's right there. It's in the second column, so it always has a 2+ charge. Okay, chlorine. Okay, always a -1. Dihydrate, hydrate. Okay, that's when it has those water molecules. Di means 2. Okay, so let's put it together. Our formula is calcium chloride dot dihydrate. Okay, all right, so let's go through and calculate the molar mass. I'll do this nice and big here, got lots of space. So we have 1 calcium, we have 2 chlorines, we have, okay, so we have, we have, see how we have 2 in front, so 2 of these, 2 waters, so each water has 2. So if I have 2 waters, we have 4 hydrogens. Okay, and then 2 oxygens. All right, so 1 calcium, 2 chlorines. So double check everything before you start because you can mess up in this step as well. All right, we're good to go. So let's go through and look at our periodic table and calculate out the mass of each here. So calcium, looking on the periodic table, I have 40.08. Okay, I'll go to the periodic table in a second. I will just kind of write all these out right now. I have my periodic table in front of me here. All right, so 2 of those, 4 of these ones, and 2 of these. Okay, so right now, I recommend showing all the work. I get that you might want to write the next step down. That's fine if you want to, like instead of writing all of, 1 times this, 2 times that, 4 times, you just want to calculate it as you write it down. That's fine as long as you show some work, but just make sure you're doing it correctly. All right, so let's just go to the periodic table. Okay, so calcium is 40.08. Chlorine there is 35.45. Okay, hydrogen's out there. You'll start actually memorizing these because you use them so much. And oxygen 16, right? We've used oxygen a few times already. So, all right, let's calculate these out. So we will get 40.08 there. Okay, and again, don't chop off any digits. Use them all. Okay, 90, just put a 0 there after. Okay, and add them up. Okay, every year I have students that, they're like, oh, I could just do this in my head, and they're adding up these values, and then they add it wrong. So just do that. I want you to do things in your head, and then just double check it with the calculator, make sure you're doing it right, just because it's one of those base numbers that you need to start off really big calculations that take a page to do, and if you mess up on this step, it's going to be really frustrating. So just double check everything that you do. Okay, so grand total 147.02. Okay, all right, so then my molar mass of calcium chloride dihydrate. Okay, calcium chloride dihydrate is 147.02 grams per mole. So this compound here, if I had 1 mole of it, 6.02 times 10 to the 23 molecules of this compound, it would have a mass of 147.02 grams. So even greater than all the other ones above. Okay. All right. So hopefully that was enough examples there so that you can kind of get comfortable and calculate some work on the worksheet and then try the checkpoint. So again, recap, you should have a kind of comfortable idea of what a mole is now. It's just a convenient way for me to, if I'm talking to you about how many things there are, instead of saying 6.02 times 10 to the 23 or 602 hexazillion, or actually say all these zeros out, I could just say a mole. I have a mole of them, okay? And then you know how many I have. Again, so a mole is just a fancy counter, and it's it's replacing a number. So like a dozen eggs replaces 12, right? A mole replaces this massive number. Okay, and we were just trying to calculate out the molar mass. Okay, so if we had 6.02 times 10 to the 23 donuts, what would the mass be in grams? That's what the molar mass is. Okay, so we went through. First, we looked just at element. Okay, so element, like the periodic table of elements. And again, if you're wondering, well, why is O2? O2 is a compound. Well, if it's the same element combined together, they still consider it to be an element, okay, but it's like an element, a compound, okay. Same with phosphorus, you can have just P, but then if you have a P4 substance, okay, it's still considered an element because there's the same element combined together, okay. So like carbon, you can have just carbon, but you can have like graphite and diamond and stuff like that. It's just all carbon, but many, many carbons. but it's still considered an element. Okay, elemental compound versus element, I guess. All right, so just yeah, that's you found the molar mass of those. Okay, then you found the molar mass of the compounds, yeah, so just make sure, do it perfectly, check your answer, every digit counts. Okay, so make sure it's perfect like that, because again, I kept saying over and over again, it's a number that you need to use, that is followed by several calculations. So if you screw up in this step, it'll mess up all your calculations and it will be very frustrating. So yeah, just be careful. Okay, so go practice.